Yeah, 5 and 6. So the so as you would have imagined by now that if you have to specify to draw a square, you had to put like 8 lines of code. Okay, you have to say forward, left, etc. Sometimes you want to write a procedure which will automatically generate a shape. Okay, so that's the next evolution of writing a code. So in this example, we are going to um, draw the shape of a turtle along a circle. Okay, so for example, it will look something like this.
Oh. So cute.
So, so the way we are doing it is first we start a screen. We create an instance of a screen class which is in the turtle module, and we call it as wn, which is the short form I'm giving for a window. Then I'm setting the background color of that window object or instance to light blue. Okay. Once I'm done with all these examples, I'll show you the documentation, and we can see what are the various options that are available. Okay. Then we have when we are creating an instance of the turtle class, and we are calling it A, and on this turtle class, now you can do all kinds of changes that you want. So you can set the shape to be a turtle, you can set the color to be black, and then I'm saying pen up. Okay, so that's why if you see the output, you see it's in the circular shape, but there's actually no line. It's only stamp of the turtle along the circular shape. Okay, that's because I have pen up there. Okay, then I'm saying size equal to 30. Then I have a for I in range of 20. Now a quick pop quiz. What will be the output? What will be the type of range of 20? Sridhar should not answer.
From this? Yes.
What's the data type?
She said list.
A list. Okay, sorry. Yes. And what will be the value in the list?
0 to 19.
0 to 19. Correct. The list will start from 0, 1, 2, 3, all the way to 20 minus 1. Okay. So which means this loop, the for loop, will run 20 times. Okay. Every time it runs, I'm saying put a stamp. Then I'm saying a dot forward by 30 pixels. Okay, so which means it's going to move in a certain direction. So let's say at the start we are at this position. I think we are at this position maybe. Okay, I'm basically saying put a stamp of the turtle so that I have the shape of the turtle. Then I'm saying move forward by 30 pixels. So it moves to this position, and the pen is still up, so there's no line going to be drawn between the two turtles. Okay, and then I'm saying turn right by 18 degrees, because if you remember, right and left is basically on degrees. So I'm saying turn right by 18 degrees, so which means it's going to point downwards. That's what you see here. It's pointing a little bit down, and then the next iteration starts. So now I equal to 1, and then line number 13 will be executed. Now it's going to put a stamp. So the turtle will now be at that position, the second position, and is pointing 18 degrees downwards. Okay. And after I'm done with it, I'm saying again move forward by 30 pixels. In line number 14, I'm saying that. Move forward by 30 pixels and then turn right by 18 degrees. Okay. So at every step, I'm moving forward by 30 pixels and then turning by 18 degrees. So if I do this turning of 18 degrees for every position, ultimately after 20 turns, I'll be back at this position where I started. Correct? Because this 360 degrees, we have completed the circle. Okay? So, for example, if let's say I change this to 10, can you guess what the output will look like? Half the circle, correct. It will only be half the circle.
It won't be as cool.
Yeah, it won't be as cool. Yeah. All right. So now, similarly, if I comment this line, for example, it won't look as cool either. There's an ugly looking line going in the middle of that. Okay. Neither one is cool. All right. Any question about that? Okay. So the next one, prepare to be wowed even more. Make sure that you don't run the code before I run it. Ah, damn. Look at that.
Oh,
It drew a spiral.
Ooh.
In this, the turtle looks kind of like a spider. So in case if you're afraid of spider, then don't look at it. Uh, so this code is very similar to the previous one. We create an instance of the screen. We call it wn. Set the color to light blue. We create an instance of a turtle class and call it a. Set the shape to whatever. Let's change it to red maybe. Just
If you reduce that window or something, why you many windows?
yeah, maybe I'll move this a little bit to the right. So that way.
Then why is it running and coming
Oh, that's the part of this guy. Okay, maybe I'll run it from here then. Total 6.py. Okay. So, so far the code is very similar. And then the pen up is also the same. It was there in the previous one. And I said reduce the size to 10 instead of 30 because the spiral is getting out of control. It was going too big. Then I have a loop which says for I in range of 30 instead of range of 20, I'm saying a dot stamp, okay, which means it's going to put the first turtle in place. Then I'm saying size equal to size plus 3, which means at every point I'm going to increase the value of the size, right? In the previous example, turtle5.py, in turtle5.py, okay, let me close all these guys. In turtle5.py, if you notice the size didn't change inside the loop. The size was set to 30 initially and it just stayed at 30 during the loop. Whereas in turtle6.py, I'm increasing the size, which means that the first iteration, the size equal to 10, and then the size now changes to 13 in this line 14. Okay. Then I'm saying move forward by 13 steps, 13 pixels, and then it turned right by 18 degrees. Okay. In the next iteration, size will be equal to 13 plus 3, which is equal to 16. So which means that every iteration, the spacing between the turtle and the next turtle will increase by 3 units. Okay, but the angle is still the same. It's still pointing at the same angle. Okay, and you keep repeating it, and you end up with a full spiral. You end up with a half spiral because I changed 10. Yeah, it's not even half. Any question about this? Did you guys try anything different? Ashley? Did you try something different?
yeah.
Let me see.
I need to read.
Any question about this? About what we have learned so far?
My code is high.
What's happening?
My code is like it's chewing up the CPU, not doing anything. I wonder what I did wrong. Yeah, I can check it.
Should be fine.
Yeah, it seems like it's very slow at consuming a lot of energy. I mean, a lot of CPU. It takes forever to come up the next level.
No, you have to go to activity. So stuck. This is the code. Right? Oh no, you haven't saved it. Something else. Yeah. It does not save, so maybe some other code that you had before, it was causing it. But when you looked at it, it looked like.
Let me see if I can make a duck shape.
I think there's only a certain option that you can put in.
Oh, what other animal?
I think there's a dot. Oh, I don't know whether there's other animals. Let's see. Let's check. So now that's why we need to look at the documentation. So if you go to total1.py, on the top of that file there is a URL which is the documentation for total. Okay, and in that documentation, let's look at the shape for now. There is a so these are the various options. You can put arrow, turtle, circle, square, triangle, classic.
Oh.
So these are the possible shapes.
What is classic?
I have no idea. Let's try. It's just an arrow. It's not fun. Although they also allow you to put an image instead of that shape. I think they allow that. Let's see. Shapes. Rectangle, tilt. Image. Background picture. There you go. There is a add shape. Okay, which can take an image. Or you can specify a shape and the coordinates of that shape. You can register a shape. Interesting. Alright, let's look at the document in a little more in an organized manner and then we can play around with it later. So, whenever you think of any object-oriented programming tool, okay, there are a few things you should understand. One is you always need an ability to set variables, which means if you have a variable called name, you should be able to set the value for that name. If you have a variable called balance, you should be able to set a value for that balance. Similarly, you might also want to get back what is the current name, what is the current balance from a class, right? So there is always what people generally call as getters and setters. If you have 10 variables, you might want to get the values of those 10 variables and be able to set the values for those 10 variables. Okay. So, in which means that whenever you're doing something with turtle, for example, you might want to get back what is the current position of the turtle. Okay, it's not just setting the position. You're not just saying move forward by this step, turn right or turn left or something like that, but you might actually want to know what is the current position. So that's why they have this method called position. Okay. Or if you want to know what angle it is pointing at, then you can get the heading. Okay. And you know how to set the position, which is using the left and the right and forward and stuff like that. Okay. We already saw pen up and pen down. We also saw pen size. Then you might also sometimes want to know, is the pen actually down or is it up? Correct? Because you might be in the middle of a complex logic, you are not kept tab of anything, you just want to know what is the state of that. You can just call is down. Okay? And if you call is down, it will just go and return a true or a false. True if the pen is down and false if it's up. Okay? So which means in your code you don't have to go around keeping tab of is the pen down or pen up. Whenever you need it, you just call is pen is down, it will return true or false. We already saw pen color. Oh, and let's first see what are the various colors that are possible. So, colors can be specified in many ways. You can specify colors like red, green, etc. There are a few choices like that. Or you can specify RGB coordinates or triplets. Okay, so red, green, blue combination triplets. Okay, and here are some examples. For example, there is 40, 80, and 120, which will give a certain color. 160, 200, 240 will give a different color. And the 160 stands for red, amount of red, 200 stands for amount of green, and the 240 stands for amount of blue. Okay, and this is the HTML coloring scheme. So if you look at web pages, they don't use RGB values for coloring. They just use these hexadecimals to specify color. Okay, you can use that also. Okay, but and this is RGB. So the first two is red, the second two is green, and the third two is blue. Okay, so that's on one way of defining color. So with that combination of RGB or the HTML way of coloring, you can pretty much choose any color you want. The whole color palette is available. Okay, and if you want to show the turtle or hide the turtle, you can use this. And similarly, as I said, you can set the property like, do you want to show the turtle or hide the turtle? But sometimes you want to know, is the turtle actually hidden? Because from the window perspective, when you're looking at it, you know it is visible. Okay, but from the code perspective, from the program perspective, it doesn't know whether the turtle is visible or not visible. So you can check whether it's visible or not visible using the is visible method. Okay. And then you can also set events, so which means you can actually start writing games with it. So the key thing about writing a game is being able to respond to events. Okay, let's take a simple fly swatter. All that you'll be responding is, it's a fly going around, and somebody swats with a swatter. You need to know the coordinate of the swatter and the coordinate of the fly, and if these two coordinates match, you say, I'm going to kill the fly. If the coordinates don't match, you say, I'm not going to kill the fly. Okay, so that's in simple sense what happens. And the event that you're trying to check is, do these two coordinates match? Okay, which basically means you have to know where the user clicked. What is the coordinate of the fly swatter and what's the coordinate of the fly? You need to know these two coordinates. And the event that triggers it is, if those two coordinates match, then you do a certain set of things. Okay, if they don't match, you say, I'm not going to do anything. All right. So using these events is how you program program a game. Okay. And on the Windows side, you can change the background color. You can set a background picture. You can clear your screen. Let's say you're drawing something, and the user clicks some button or some event happens. You want to clear it and restart again. For example, in the fly swatter is a good example. You have a fly that's going around. You kill. And then you want to restart by saying, I'm going to clear everything and I'm going to give a new fly that you're going to swat again. Okay. To clear the screen, you can just use clear. Okay. And more event handling in the Windows side, not just the turtle side, but even on the Windows side. All right. I think that's pretty much all I have. Do you guys have any questions? And this URL is in turtle1.py, right at the top. Yeah.
Do most games use Python code?
I don't program games, so I'm not 100% sure about it. But if you're talking about a game that's pretty sophisticated, like I used to play Counter-Strike a long time back. Those kind of games generally are written with a language like C or C++, because they need to be more performant.
Yeah, for speed.
For speed, yeah, for speed. But if you are talking about a small game that you might be playing that's looks like it's built in 1980, you can program it in Python. It'll be probably fewer lines of code, and you still get the fun of writing the game.
There is a cross-platform called Kiwi.
Yeah, that's KIVY. So there is this Python module called Kiwi. Okay. The cool thing about this platform is it allows you to develop a mobile application using Python. Okay. But it's not exactly the same as developing with iOS or Android or Java. Okay. because the UI doesn't look exactly like a typical iOS UI or a Android UI. Okay, so when it comes to developing a day-to-day application that everybody uses, that's not a game, Kiwi doesn't cut it well. But it's actually pretty useful when it comes to creating games. For example, let's see. Ah, excellent. It says undefined. See a game like this. Okay, it doesn't matter whether it's an Android or iPhone. Even in Android, it might look exactly like this. Like many games in Android look like this. Okay, completely cartoonish. Okay, or in iPhone also, it's the same thing. So you can develop games like this using Kiwi. And the advantage of using a tool like Kiwi is it provides multiple. So you can program at a really low level where you control every event, or you program using a more higher level module like Kiwi, which will abstract lots of complicated things away so that you write less code but you get the same effect. Okay, and Kiwi does that. It's pretty useful. So if you want to learn gaming, this would be a good tool to start. Okay. Kiwi, and you can compile your code and make it run on your mobile phone also. It's not exactly as powerful as running it on writing it in Java or Swift or iOS, but it still does its job.
You mean I learned a lot wrong language?
Sorry. So here is another game that was developed with Kiwi.
So what is Python mostly used for, like in the industry?
So these days, data science and machine learning, there are basically two languages that are ruling that domain, the complete domain, R and Python. And Python is much more popular than R in that respect because with Python you can not only just do your data science, you can put a website that can be used to serve the data science solution. Okay, or you can write a desktop application which can be used. You can give it to somebody and they can run the code, get all the calculation, show the visualization, make decisions and things like that.
Yeah, Python's basically used if you want to do simple machine learning, if you want to create websites, or you're like Google. So it's used for those three. If you want to program for the Android, you use Java. If you want to program for iOS, you use Swift.
Yep.
But it's one of the better languages for websites. There's a couple others as well.
Yep.
The thing is, MATLAB or R, if you're a real data scientist,